Bismillahirrahmanirrahim. Now we started this 7.1 area of region between two curves. We explain it to explain the three cases, and we did some examples. Let me go back over these three cases, which is very clear. If I have area between two functions where I have an upper function and lower function, I have this strip, so the area will be the integral from A to B, from A to B, of the difference between the upper minus the lower. Sometimes I need to do it in terms of Y. I need to do it in terms of Y. But now it will be the one to the right minus the one to the left. Everything in terms of Y. Also, the limits of integration, they are Y equals C and Y equal D. So everything in terms of Y. Note this. It's better to do it this way. Otherwise, I need to split it into many parts, which will make it very complicated. But if I am doing it in terms of Y, there is no need to split it into parts. Okay. Sometimes the function will go up and down, then up and down. So there is a change in who is the upper, who is the lower. Like in this case, like in this period, I have, so from A to this, I have F is the upper and G is the lower. However, in this period, I have G is the upper and F is the lower, and so on. So you need to take it case by case, or you can write the, if you have only two functions, you can write the absolute value and be careful when it is positive. Okay, let me do more examples. Yeah, if x equals sine, I want to find the integral, the definite integral. Just he wants me to find the definite integral. He's not talking about the area, just only the definite integral. So you have from 0 to 2 by sine x dx. And that give me what? Minus cosine x from 0 to 2 pi. And that will give me minus cosine x minus cosine 0. And that is minus 1 minus 1 minus 1 plus 1. Will give me 0. Okay. However, when I want to deal with the area, I need to be careful. If you graph the function, part B, you need to be careful here. This is the sine. Let me give it some space. This is the sine. Go up, go down, turn back. This is from 0 to 2 pi. There is a change. This one, there's a change in the upper and lower. Oh, and this point is pi. So be careful about that. Now the area, I need to split it into two parts. I have A1 and I have A2. What is A1? The area will be A1 plus A2. Let me do A1. A1 will be the integral from 0 to pi. What is the upper? The upper is the function, y equals sine x. And the lower, I equals 0. So it is sine x minus the lower, which is 0. Yeah, I know it's sine x minus 0, sine x, but just for completeness, I'm doing it this way. So that will be minus cosine x from 0 to pi. Now do the calculation. That will be minus cosine pi minus cosine 0. Cosine pi is minus 1, minus 1, that is 1. And that cosine 0 is 1, so 1 plus 1, that will be 2. A2. A2, now it will be from where to where? From pi to 2 pi. Be careful now about the function. Now the upper is y equals 0, and the lower is y equals sine x. So I have 0 minus sine x dx. You can do it with that value, or I think that this way explain it. 2 pi minus sine x dx, which give me cosine x now, between pi to 2 pi, and that give me what? Cosine 2 pi minus cosine pi, which is 1. Cosine pi is minus 1, minus 1, that will be plus 1, that will be 2. So this is 2 plus 2, which is 4. Okay, so I find the definite integral, I'm getting 0, but I'm finding the areas, I'm getting 4, which is very clear. Definite integral, it means a1 minus a2. Now, but if I find the areas, it will be the sum. Okay. Find the area of the region between the x-axis and the graph of this. I need to be careful about the graph of this function. Yeah. First, I notice the zeros, f of x. I can rewrite it so that I can grab the function x squared minus x minus 2, which is x minus 2, x plus 1. Okay. So the function will do something like this. I need the point minus 1. Okay. And 0 and 2. These are the most important points. If I take a value before minus 1, minus 2, just I want to sketch the graph of the function. Minus 2, that give me negative, 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 so it's negative. So it will do something like that. Reach minus 1. Since all of them are linear, then it will cross it and go up, go down, and go up like this. That will be a sketch of the function. So now it's very clear what to do. Now the same thing, I have A1 and A2. Okay. So what is A1? A1 will be the integral from minus 1 to 0 of the function minus 0 of the function. Minus 0, which has no meaning. Minus dx. That give me what? X to the power 4 over 4 minus x cubed over 3 minus x squared. And this is from minus 1 to 0. We do the calculation. That give me what? 0, 0, 0. So it will be 0 minus 1 over 4 minus minus, that will be plus 1 over 3 minus 1. That is what? Minus, yeah, this is what? 7 over 12 minus 1. That will be minus 5 over 12. So the answer is 5. Okay. A2 will be the integral from 0 to 2. But now what we have? We have 0 minus the function. 0 minus the function. So I have what? Integral from 0 to 2 minus x cubed plus x squared plus 2x dx. Now it's a matter of calculation. Minus x to the power 4 plus x cubed over 3 plus x squared. That from 0 to 2. Do the calculation. That'll give me what? Minus 2 to the power 4 is what? 16. So it's minus 4. 16 over 4 plus 8 over 3 plus 4. So it's 8 over 3. So it will be the area A1 plus A2. And that will be 5 over 12 plus 8 over 3. This one times 4 is 32. So I have 37 over 12. Okay. Sometimes he give me the function. Now what we want, you want to find the area of the region bounded above by the curve. This is the curve. This is bounded above by the curve. Below by this curve, by another curve. Okay. On the left by x equals 0, and the right by x equals 1. Very clear that now if I do the strip, usually this strip will help to show you what is the upper, what is the lower, and is it for all the area? Yes, if you take it here, if you take it in any place, it's the same thing, the upper and the lower, there is no change. And this one, there is a change. Huh? If I put it here, different than putting it here. Like the same with cosine, with sine. Okay. Now, this one will be the integral, the area, one integral I have from 0 to 1. The upper, which is this function. Okay. So it's 2 minus x plus x minus the lower, which is this one. Dx. Now we do the calculation. Now we just do the calculations. What we will get? Minus 2 minus x plus x squared over 2 minus half ax, all of this from 0 to 1. Okay, that give me what? Minus 2 over e plus half minus half e. Okay, minus e to the power 0 is 1, so that's minus 2 plus 0 minus half. But e to the power 0 is 1. Yeah. That'll give me what? I have half here. Let me do it in a step. And then I have minus 2 over e minus e over 2. Then I have the numbers plus half plus 2 plus half. So I have 3 minus 2 over e minus e over 2. That will be the answer. Find the area of the region closed by the parabola and the line. Okay, so I need to graph the function to see the area. Y equal 2 minus x squared. This is 2. This is the function. And they have the line y equal minus x. Okay. Y equal minus x, sorry. Y equal minus x, not y equal x. It's the other way. It means I'm looking for which area? I'm looking for this area. This is the area between them. Okay. So if I do this strip, yeah. This will be the upper. The parabola will be the upper, and the line will be the lower, and it's all the way. So I need to find these points. How to find these points? I just equate the two functions. So I need to find points of intersection. Which is y1 equals y2. I just equate the functions. I have an equation, I try to solve it. I'm getting what? X squared minus x minus 2, which is equal to 0. So I have x minus 2, x plus 1 equal to 0. So I have x equal minus 1 or x equal 2. So this point is minus 1, and this point is 2. So I have my area, will be the integral from minus 1 to 2, the upper, which is the parabola, minus the lower, which is minus x dx. Now just a matter of calculation. 2 minus x squared plus x. That gives me 2x minus x cubed over 3 plus x squared over 2 from minus 1 to 2. That gives me what? 4 minus 8 over 3. 4 over 2, that will be plus 2. Minus 2 minus 1/3, that will be minus 1/3, or plus. Yeah, it will be plus. Minus, so it will be plus half. Yeah, if we do the calculation, that give me what? I have 4 plus 2 plus 2, that give me 8. Minus 8/3 minus 1/3. That give me minus 7/3 minus half. Yeah, do the calculation. 8 minus, this is over 6. I have what? 14 plus 3. It's like I'm taking minus and common factor. That will be 14 plus 3. So I have 8 minus 17/6. That will be what? 48 minus 17/6. That give me 31/6. I'm not getting the same answer. 4 plus 2 minus 8/3 minus 2 plus 1/3 plus 1. Okay, this calculation is correct. So I have 4 plus 2, 6 plus 2, that is 8. And they have minus 8/3. Sorry. Be careful sometimes with these fraction things. Yeah. So I have minus 8/3 minus 1/3. So that will be minus 9/3. Yeah, that will make it minus half. So it's 8 minus 3 minus half, which is 5 minus half. That will be 9/2. Yeah. Find the area of the region in the first quadrant that is bounded above by y equals square root of x and below by the x-axis, underline this. Okay. So always we need to graph the function. I have this. So this is the upper bound. Okay. And I have the line y equal x minus 2, which is at 0, it's minus 2. Let's do something like this. This will be my area. And below by the x-axis, so I'm talking about this area. So the x-axis is there, underline. So we are talking about this area. This is the area we're talking about. Because he said by the x-axis, underline. Below, by the x-axis and underline. So I have the x-axis here, underline here. So I have this place. Now you need to be careful. If I do the strip, here, this is the upper, this is the lower. Here, this is the upper, this is the lower. But doing it here is different. Now the lower will be different. So I need to split it into 2 parts. Okay, so I need this point. So I need to find the intersection. Okay, I need to find the intersection. By the way, y-axis معناها y equals 0. Intersection between what? This is y1. Let me call this y2. This is y3. This point I need to find it, which is the intersection between y1 and y3. Okay, and also I need this point where I have the split. This point is 0. خلاص, clear. This point, which is the intersection between what? The line and the x-axis. So also between y2 and y3. I need this. And to find this intersection point. For sure, this will be 2. No need to do anything. This is 2. Yeah. This is very clear, it's 2. Now for this one, I need to do some calculation for this one. So this is the intersection point, x equal to. Yeah, because I will do x minus 2 equals 0. So I have x equal to. Nothing to worry about. For this one, I need to do some calculation. So I have square root of x equal x minus 2. I just equate the functions. I have x equal x squared minus 4x plus 4. So I have x squared minus 3x plus 4 equals 0. No, what the minus 5x, sorry. So it will be x plus 4 times x plus 1 equals 0. X minus 4. Yeah. It means x equal 4 and x equal 1. One is not acceptable. One will not satisfy the equation. If you plug it here, I'm getting 1 equal minus 1. You know, when you square, sometimes you need to check. So the only solution, x equal 4. So this is 4. Class. Now, what will be my area? I have two areas. If you do this, then I have A1, I have A2. What is A1? Well, let me see, this is A1. Yeah. This is A1 and this is A2. A1 will be the integral from 0 to 2. What is the upper here? With the strip. The upper will be the square root of x, and the lower is the 0. Square root of x minus 0 dx. Now, if we do the calculation, that gives me what? Yeah, that gives me x to the power half. So it will be 2 over 3. X to the power 3 over 2 from 0 to 2. Yeah. And that is what? That is 2 over 3 square root of 2 cubed, which is 2 square root of 2 minus 0. So it will be 8 square root of 2 over 3. Now we'll go to A2. A2 will be what? Now A2, if we do the strip, it will be the square root minus the line. And it is from 2 to 4. So the square root of x minus the line, which is x minus 2 dx. That I need to do the calculations carefully. Square root of x minus x plus 2 dx. That will be 2 over 3. X to the power 3 over 2 minus x squared over 2 plus 2x. That from where to where? From 2 to 4. Okay. 2 to 4. 4, I have what? Square root of 2. Square root of 4, which is 2 cubed. So I have 8 times 2, 16 over 3. Minus 4 square, which is 16 over 2. That will be minus 8 plus 4. There's 1. Minus, plug the 2. I have what? We did it before. That will be 8 square root 2 over 3. Yeah, since it's 8 square root of 2 cubed. 2 square root of 2. No, it's not. Yeah. Not 8. So 2 times 2 is 4. Sorry. This is 4. Yeah. Minus 2. 4 over 2, that is 2 plus 4. This is will be what? I have here minus 4. And I have here 2 with the minus. So that give me minus 6. So I have 16 over 3. Now what is this? This is 4. This is 2. 4 this is 2. So I have 16 over 3. The numbers is what? 4. And this is 2. with the minus, so it's minus 2 minus 4 square root 2 over 3. That will be A2. So it will be the area, will be A1 plus A2, which is 4 square root 2 over 3 plus 16 over 3 minus 2 minus 4 square root 2 over 3. This is cancelled. 16 over 3, that's 16 minus 6 over 3. That gives me 10 over 3. And that will be my answer. Okay. Now, he wants me to do this problem, but with respect to y, which is, will make sense, will make, yeah, which is better. Y, we know this. This is the graph, but we need to be careful a little bit. This is the line, huh? And I'm talking about this area. That's one thing. If I'm doing it in terms of y, this is strip, I don't need to have two areas. I will take only one area, because always it will be the one to the right minus the one to the left. There is no change in the larger and smaller. But now I need to write everything in terms of x. So it means I have here x equal y squared, and I have here x equal y plus 2. So I need to write everything in terms of x now. Not only that, I need to find 0. This is, I know as an x value, this is 4. But I don't care with it. I don't care about it for the x value. I need the y value. And that will be 2, since dealing with the square root of x. Square root of 4 will be 2. So now the area will be what? It will be from the y values from 0 to 2. From 0 to 2. The one to the right, now the one to the right is the line, which is the line in terms of x. I will do it, huh? So I have f of y, since the first time I'm doing it, minus g of y, dy. What I call this is f of y, and I call this g of y. I wrote everything in terms of y. So that will make it easier for me. I have only one area. No need to split it into two parts. F of y will be what? Y plus 2 minus y squared dy. Now it's a matter of calculation. Y squared over 2 plus y minus y cubed over 3 from 0 to 2. That will be what? 4. 4, not 4, 2. 2 squared, 4 over 2. 2 plus 4 minus 8 over 3. That will be 6 minus 8 over 3. Because it's minus 0. Who cares, huh? That gives me what? 18 minus 8, 10 over 3, which is the same answer. Yeah, which is the same answer. But here we make it two areas. There, no need to make it two areas. So sometimes it's good to do the integral in terms of y, not in terms of x. That's my idea. Okay, let me do more problems. Yeah, he gave me the graph. He wanted to do the total area of this shaded region. Okay. Now I will do the strip this way. Okay. And they have it from where to where? From 0 to pi. So the area will be from 0 to pi. What is the upper? The upper is 1, and the lower is cosine square dx. 1 minus cosine square dx. Okay, this is the upper and this is the lower. This is y1, this is y2. So you have y1 minus y2 from 0 to pi. Okay, let me do the calculation. Now it's a matter of integral Oh, 1 minus cosine square is what? Sine square. How to do sine square? Don't forget that. I need cosine 2x equal 1 minus 2 sine square. So that gives me what? 2 sine square will be 1 minus cosine 2x. So sine square will be half minus half cosine 2x. So that means from 0 to pi, first I rewrite sine square as half minus half cosine 2x dx. Now I will integrate half x minus, or minus 1 over 4 sine 2x. You can do it by substitution, or you can do it directly from 0 to pi. You can check if you can't differentiate this. I have minus 1 over 4 times cosine 2x times 2, so I have minus 1 over 2 cosine 2x. Now substitute, I'm getting pi over 2, sine 2 pi is 0, minus 0, minus 0, minus 0. So I'm getting pi over 2, which is this one. Okay. Find the total area of the shaded region. Okay. I need to be careful here. Yeah. Or now, if we're making it in terms of x, we'll be in trouble. Because here I need to deal with it, and here I need to deal with something else. So that will make it very complicated for me. However, if I'm dealing in terms of y, we do the strip here, or do the strip here, I am always getting the one to the right, minus the one to the left. I think this is the one to the right. Call it x1, this is x2, and this is already actually x1, x2. Just I need to find what are these. Yeah, you want all of this. So I need these points. It gave me the intersection one. No, I don't need this point. Actually, I need to do it in terms of y. So I need this and this. That's it, because I'm doing the strip this way. So the will be, I need 0 and 1. I don't need these points, since I'm doing it in terms of y. So I have the area will be 0 to 1, huh? In terms of y, huh? x1 minus x2 dy. Yeah. Like what we did here. We're making it dy, huh? Okay, that give me what? Yeah, that give me